Hello, hello, this is Mr. Vaughn with video lessons 8.5 through 8.7. So we're continuing on chapter 8, moving off of function tables and moving into inequalities. And this is a pretty simple concept, so I hope you guys can get it pretty quickly. If you need some references, need to look at some examples or things, vocabulary words, look in your California Math, pages 626 through 637. I also wrote down the page numbers here for each section of the notes and where they go in the chapter. So, some symbols first. You might have seen this already. I don't know if you got this in elementary school or not, but you know already that this means greater than and this means less than. And all they've added for this is a line underneath it. You see this line underneath it. That means greater than or equal to. Greater than or equal to, and then obviously this one that's facing this direction means less than or equal to. So if I have a value and I'm not sure what it is, I'd say x is, oops, not equals, that's not what we're doing. It is an inequality, is greater than or equal to 8. So that just means I don't know what x is, but I know that it's above 8, that's the greater thing, or it might even be equal to 8. So that's the difference between this, x is greater than 8. That does not include 8. That means x has got to be 9 or bigger on this one. But on the top one, greater than or equal to includes 8. Let me back up a second, and you can see inequalities has got the suffix or prefix in it, so that means they are not equal. So we know that x is not, it might be equal to 8, but that's where the inequalities, the word comes from. I'm talking too much. So that's the quantities. Look at lesson 5 on page 618 if you need some more help with that. Moving on to lesson 6, this is graphing the inequalities. So what you're going to do is we'll just we need smaller numbers for this because my graph does not go that big. So let's say we have n, some number, and it is greater than, oops, that's not going to fit on here either, greater than 3. My examples are bigger than my number line. So greater than 3. So that means you go out to the number, okay, and put a dot there. Right, you can put a dot right on it. A dot right on it. Now, in this example, n is greater than 3. Does that include 3? No, that's not including 3. That means it's greater than 3. So the open dot, see right here, there's nothing filled in there, means that it's not equal to it. It's just above it. And then you do a line like this, on or above the number line. That shows that n is greater than 3 and doesn't include 3. Let's do another example. N is less than or greater or equal to negative 2. So in the second example, we think that we know that n is less than negative 2, and it may even be equal to negative 2. So how you show that is you go to negative 2, just like you did for the first example, but instead of an open dot, you make it solid. That indicates that it is greater than or less than 2, or it may even be equal to 2. And then you do a arrow or a line with an arrow going in the opposite direction. Okay, that's all there is to that. I would put somewhere on my notes, because I always have to look this up myself even. An open dot means not means, I'll clean these up for the notes you're copying. Not equal to. A solid dot means could be equal to. And you know what? I'm going to reword that. I'm going to use the word included is better. An open dot means that, like in our example here, 3 was not included. Not includes the number. And a solid dot means that it is including the number. includes the number. So does that make sense? Hopefully it does. We'll be going over it in class if not. And I wrote the steps down here. So a dot on the graph, an open one or a solid, then a line above it with an arrow going whatever direction they're telling you to. Alright, so solving inequalities. You guys are going to love this since you are a lot of the way there already. Let me make a little bit more room for myself. Thought I was all set up. I think we need a little bit more room. This is just like, we can see the steps right there. It's just like solving a regular algebra equation, and you leave the sign as is. Where are my examples? Here they are. So we're going to say y minus 5 is greater than 20. So you notice instead of an equal sign, it's a greater than sign. You do this the exact same way we did in Chapter 7. Just solve it. The operation subtraction. So in order to isolate the variable, I use the inverse operations. I'm using big vocabulary words. I hope you followed that. Instead of an equal sign, I'm using greater than. There's nothing left on the left but y. I added 5 to that side, so I add 5 to this side, and we know that y is greater than 25. You're done. That's it. That's all. If this was a greater than or equal to thing, it could be the exact same way. Doesn't matter. So those are solved just like regular algebra equations, and you just leave the sign facing whatever direction it is. If you need more information, 636 and Lesson 7, that's where you will find it. Mr. Vaughn is out.